Oftentimes in organic chemistry, you will find a charge associated with a molecule or an atom. In a lot of cases, unlike general chemistry, where you just memorize the charge of ammonium, for example, we need to show which specific atoms are charged. So we will add a formal charge to the atom, and a formal charge is basically a positive or negative charge found on a single element as a result of an unusual number of electrons. So let's take that example of ammonium, NH4+. We know that nitrogen typically has 5 valence electrons. This means we have 3 sites available for bonding. In this case, though, ammonium has 4 hydrogen atoms. So there's a charge associated with this that allows us to get an extra bond. That charge is basically loss of this 1 electron here. So now we have a 4th site available for bonding. So if we were to draw the Lewis structure of ammonium, we'd have our nitrogen with 4 bonds. And because the nitrogen lost an electron to make that 4th bond, it has a formal positive charge. As a shortcut for how to find a formal charge on a molecule, basically we take our nitrogen, we say it typically makes 3 bonds. In this case, it's making 4 bonds, so its formal charge is +1. Moving on, carbonate, CO3 minus 2. First, we're going to draw a carbon connected to each of our oxygen atoms. Each oxygen has 2 lone pairs. And the carbon can make a 4th bond, so we'll make a bond to this top oxygen. Now, the 2 bottom oxygens each have an unpaired electron. They only have 7 valence electrons, but the charge of the overall molecule is -2. We'll add an extra electron here to this oxygen, giving it a formal negative charge, and an extra electron to this oxygen here, giving it a formal negative charge. If we want to use our shortcut, if we're looking at this first oxygen here, oxygen typically makes 2 bonds. It's making 2 bonds, so it has no formal charge. This oxygen here typically makes 2 bonds. In this case, it's making 1 bond. It is a formal charge of -1. Next up, let's take a look at azide, N3-. Let's connect our 3 nitrogens together. Each nitrogen has a lone pair of electrons. The nitrogens on the left and right side each have 1 more unpaired electron, and the nitrogen in the center has 1 unpaired electron. Now again, we've got a negative charge on our formula, so let's add that to one of the nitrogens, giving it a -1 charge. Now, if we take a look at how many unpaired electrons we have, the nitrogen on the left has 1, the central one has 1, and the one on the right has 2. This tells us that the central nitrogen can make a new bond. But if it does that, we still have a lone pair here which can't bond. So we're going to have to lose one of these electrons and add it to a different nitrogen. In this case, we're going to add it to the one on the right because the nitrogen on the left already has a charge. So that becomes negative, and this becomes positive. Now we have an unpaired electron here and here, which can bond. So let's clean that up a little bit. Each nitrogen has a double bond to the central nitrogen. Each terminal nitrogen also has a lone pair. And we have to assign our formal charges. Nitrogen on the left is minus, nitrogen on the right is minus, nitrogen in the center is positive. Again, if we want to use the shortcut, nitrogen typically makes 3 bonds. In this case, it's making 2, so it's -1. This one here typically makes 3 bonds. Now it's making 4, so it's +1. Finally, let's take a look at nitrate, NO3-. Again, we're going to make bonds to nitrogen and 3 oxygens. Add in our lone pairs and our unpaired electrons. Okay, we have a negative charge here. We'll go ahead and add that to one of the oxygens, giving it a formal negative charge. And now we see that the nitrogen has a lone pair, so it can't bond anymore. We'll take one of the electrons away, giving a formal positive charge to the nitrogen. Give that electron to one of the oxygens, formal negative, and now we can make a new bond here and here. So if we clean that up, add in our formal charges. We've got each element here with 8 valence electrons and charges where appropriate. If we want to do the shortcut, this oxygen here typically makes 2 bonds. It's now making 1, minus 1. Nitrogen typically makes 3 bonds. Now it's making 4. It's plus 1. This oxygen here typically makes 2 bonds. It's making 2, so it has a 0 charge. The overall charge of the molecule is minus 1. Basically, the negative here and the positive will cancel out, leaving us with a net charge of minus 1.